Hi guys, I'd like to welcome each and every one of us to my channel of Honesty Sciences and Mathematics TV channel. I'd like to request members to kindly subscribe to our channel and also click that notification bell for various uploads that we're going to do or we have already done. And also, we can check our description boxes for various links of videos that we have done on various topics in mathematics, physics, and chemistry and biology. And also, these are going to assist us try to, of course, have a discussion on these various topics. Engage us in the comment section for more, and also kindly like our videos so that we can be able to be having a healthy engagement. So for today, we're going to look at a concept in the cylindrical coordinate system. And this basically is going to complement on the first two videos that we've done on the spherical and the, of course, the rectangular coordinate systems respectively. So this basically is going to be a concept of base vectors. And as we said, we can be able to illustrate base vectors as unit vectors which lie along the, of course, these three axes of x, y, and z. And of course, are going to be parallel to this specific axis as I've mentioned. So for cylindrical coordinate system as well, we can be able to express the unity vectors, or those unity vectors at a particular point. And in this case, I've chosen a point P, which is going to define a point for the extension of this angle, or rather the range for the radius r. And then we have pi, and then we're going to have, so this is going to be defined by three basic points. We're going to have r and the z. So this is going to be phi and the z given as such. So these are the three services which are going to define a cylindrical coordinate system. And therefore, the unit vectors for those various directions for r, phi, and z are going to be illustrated using a for r, and then a for phi, and then a for z. And those are going to form the unit vectors for these three basic services of the cylindrical coordinate system. And just as we had already looked at in various discussions, we're going to see that these various points are going to be oriented this specific point over P, whereby we're going to have the point AR, which is going to be a unit vector in the R direction that is going to, of course, be parallel to the X, Y plane. So therefore, we're going to have this specific set for AR parallel to this specific set, and going to be an extension that is going to project outward or radially. I can give this point. So this is going to be, perhaps I can use a different illustration for this. So this extension of R is going to be radially outward from the surface of this specific cylinder. So therefore, it's going to be radial and extending outward as I've given that specific point. So we're going to have a second bit for this Fi, and Fi is going to lie in the plane that is going to be parallel to the XY direction. Of course, if you try to look at this, therefore it's going to be parallel to this specific plane, XY plane. Therefore, it's going to be indicated in the position, which is a position of increasing range of phi. We said that phi is going to consist of an extension of an angle from this ZX plane, where thereby we expect the ZX plane to be lying at the point of phi is equals to 0. So therefore, at this specific point, we're going to indicate this vector in this direction, whereby phi is going to be increasing in that specific direction. And this point is going to lie in the plane parallel to x direction, and it's going to be tangential to the surface of the cylinder. And of course, we're going to be seeing that it's going to lie in the position of increasing phi. And lastly, we're going to see the third set of a z, whereby the vector for az is going to lie along this specific direction, z, and it's going to lie in the position of increasing z, and it's going to be perpendicular to the z-axis that we have mentioned. Just like the first two sets of the Cartesian coordinate system, we can be able to assign a vector of a point P using these base vectors, and this is going to be given in terms of course, the r, phi, and z, whereby we had said that the vector P is going to be given by using PR, whereby we had said that is r is the radius, and this is going to be accompanied by unit vector for r, and then we're going to have P phi and then a phi given as such, plus P z and az using that specific vector. So that is going to represent the vector, base vector for this specific set of points in the cylindrical coordinate system. So I hope that in collaboration with the first two videos that we have done on the spherical, rectangular, the Cartesian coordinate system, this is going to assist us, of course, appreciate this the definition of these specific points. We have said that these are going to be mutually perpendicular points, which means that they are going to form right angles with these various aspects for r, phi, and z respectively. So this is going to form our last bit of a discussion on the base vectors, and of course, we are going to be mentioning these videos in various areas of their applications as we go ahead. So check in our description boxes for various links of other videos which are going to be the same or rather related, or rather you can find some areas of applications of this specific discussion as I've mentioned. So that is it for now, guys. Bye. God bless you.